Welcome to This Explainer. Today, we're not looking at some flawless textbook victory. Oh no, we are diving into one of the most terrifying, heart-pounding events in human history. We're talking about a catastrophic disaster that, against all absolute odds, became known as a successful failure. We're heading back to April 1970 to look at Apollo 13. Well, you know what's incredibly bitter about this whole story? It's the sheer irony of the public's perception at the time. I mean, just months prior, when Apollo 11 landed, 70 lakh, or 7 million people, were completely glued to their televisions. But by the time April 1970 rolled around, going to the moon was kind of seen as yesterday's news. The public had grown so dangerously complacent that major networks entirely ignored the Apollo 13 launch. They seriously considered a journey into the hostile void of space to be just another routine flight. Okay, let's dive into this, because let me tell you, this was not going to be a routine flight at all. Just imagine for a second being inside a tiny tin can, 400,000 kilometers away from your home planet, and suddenly, literally everything keeping you alive starts shutting down. Today, we're going to see exactly how a standard scientific space flight shifted in the blink of an eye into an absolute desperate fight for survival. Section 1. Routine Flight to the Moon. To set the stage for us, Commander Jim Lovell and his crew were about 55 hours into their journey, fully expecting to land on the moon in just a matter of hours. Everything was perfectly nominal. The crew was floating around, casually showing off their zero-gravity life on a live broadcast back to Earth. And remember, practically no one was actually watching this on TV. The astronauts were completely relaxed, cracking jokes, totally blissful, and unaware of the absolute nightmare that was about to unfold just minutes after they signed off. Section 2. Anatomy of the Spacecraft. To really wrap your head around the magnitude of this disaster, you kind of have to think of the ship like a living organism. Think about this biological breakdown. First, you have the command module, that's the brain. It holds the crew and all the complex navigation computers. Then you've got the service module, which is the absolute heart of the ship. It's constantly pumping all the life-saving electricity, water, and oxygen directly into the brain. And finally, you have the lunar module. Essentially, it's a small lifeboat, and its one and only job was to drop 2 men down to the moon and bring them back up. Section 3. A heart attack in space. Because out there in the cold, unforgiving vacuum of space, this beautifully designed machine was about to suffer a literal heart attack. Let's look at how incredibly fast things went wrong. Houston, Mission Control requested a totally routine cryostir. You see, liquid oxygen tends to settle into layers in the cold of space, so they use a fan to stir it up. But when astronaut Jack Swigert hit the switch, a short circuit sparked inside Oxygen Tank 2. Boom! A massive explosion rocked the spacecraft, violently blowing a 13-foot panel completely off the side of the service module. Now, the crucial thing to understand here is the number 2. Out of the 3 vital fuel cells powering the entire ship, 2 were instantly destroyed in that blast. And as Commander Lovell looked out the window, he saw a truly horrifying sight. Their last remaining oxygen tank was visibly venting its contents, just bleeding out like a wounded animal directly into the endless abyss of space. Section 4. The lunar lifeboat. Right, so with the heart dead and the brain rapidly losing power and oxygen, the crew faced their first massive survival hurdle, getting out. Just think about the terrifying math for a second. They had to abandon the dying command module and pile into the tiny lunar module. But this little craft, it was only built to keep 2 men alive for 20 hours. Now, it suddenly had to sustain 3 grown men for 4 agonizing days. The ticking clock began instantly. They had to drastically cut power, meaning absolutely no heaters, and they had to severely ration their water, down to just 1 tiny glass per day per person. And the crazy thing is, they couldn't just hit the brakes and do a U-turn back to Earth. The main engine on the damaged service module might literally explode if they tried to light it. So they had to go the long way around. They shut down the main module, flew over 400,000 kilometers all the way around the dark side of the moon, and used the moon's gravity as a massive slingshot, firing the fragile lunar module engine to hurl themselves back toward Earth. Section 5. Suffocation and freezing. Now, in space, solving one impossible problem usually just immediately leads to another, and this brilliantly illustrates the next crisis. With 3 men breathing heavily in a 2-man ship, carbon dioxide was building up to completely toxic levels. They had fresh chemical filters in the dead command module, but they were square. The slots in the lunar module were round, because of course they were made by completely different companies. Guided by Houston, the crew had to pull off the ultimate life-or-death jugaad, a literal space hack using plastic bags, cardboard, and random ship parts to basically fit a square peg into a round hole so they wouldn't suffocate. But man, the physical toll on these guys was just brutal. Because they had to power down almost everything to save the batteries for re-entry, the heaters were off, and space is unimaginably cold. The temperature inside plummeted. Condensation froze on the walls. The windows completely iced over. The astronauts were subjected to freezing temperatures, severe sleep deprivation, and immense psychological strain as they slowly, silently crept closer to Earth. Section 6. The agonizing re-entry. So, as Earth finally comes into view, the final and most incredibly dangerous obstacle was approaching. The margin of error here was absolutely razor-thin. When you re-enter Earth's atmosphere, you have to hit a highly precise angle. If you come in too shallow, the spacecraft will literally bounce off the atmosphere like a stone skipping across a pond, sending them out into deep space forever. If you come in too steep, the friction will incinerate the ship. And because their main navigation computers were mostly powered down, this exhausted, freezing crew had to manually fire the engines using the horizon out the window and a simple wristwatch to thread the needle. As they hit that final stretch, they powered the dead command module back up using the absolute last drops of battery juice. Then, they jettisoned the service module. Now, this is wild. This was the very first time they actually saw the damage with their own eyes. There was a massive, terrifying crater blown completely out of the side of their ship. Next, they said their goodbyes to the lunar module that had saved their lives, jettisoned it, and plunged down into the 5,000-degree fire of re-entry. Just think about this specific duration of time. Every spacecraft going through the intense heat of re-entry experiences a communications blackout. Normally, that lasts about 3 minutes. But for Apollo 13, the silence just stretched on. 1 minute passed, then 2, then 3, 4 minutes. 4 minutes and 27 agonizing seconds of absolute, terrifying silence. The entire world was holding its breath, wondering if the heat shield had survived that initial explosion, or if the parachutes had frozen solid. And then, a voice crackles over the radio. They made it. They splashed down safely in the Pacific Ocean. The mission to land on the moon had failed entirely, sure, but the mission to save these 3 men, that became absolutely legendary. The incredible, relentless teamwork between the engineers in Houston and the courageous crew in space turned a surefire disaster into what is now known universally as a successful failure. So, what does this all mean for us? It leaves us with a pretty profound thought. When everything goes right, we celebrate the technology. But when everything goes completely disastrously wrong, that's when we get to witness the true resilience of the human spirit. So, I'll leave you with this question. Is surviving a catastrophic disaster a greater testament to human ingenuity than a flawless success? Think about that for a bit and keep exploring the